Alright, big ugly one. Construct a truth table for not P or Q if and only if not R. So we'll look first at the not P column. So we'll go, if our P column here, we're going to negate that, so true becomes false, and false becomes true. Alright, our next column is going to be looking at not P, and it's going to be looking at Q. And again, this is our OR statement, meaning if either one is true, this is true. So in our top one, Q is true. In our next one, Q is true. In our next one, neither one is true, so this is false. In the next one, neither one is true. In our next statement, Q is true, and Q is true. And in the next one, not P is true, and not P is true. So it looks like we're true everything except for case 3 and 4. Alright, in the very end, we need to compare that column we just had to the negation of R. In order to do that, let's get the negation of R. True, false, true, false, true, false, true, false is going to become false, true, false, true, false, true, false, true. And finally, we're looking for the biconditional of these two columns. And the biconditional is true only when these two columns match. So in the first one we got a true false, so our biconditional is false because our two values don't match. Case 2, we've got a couple of trues, so the biconditional is true. Case 3, we have a couple of falses, so the biconditional is true. Case 4, we have one of each, so it's false. The same for case 5. Case 6, we're both true, so that's going to be true. Case 7, we've got one true and one false, so that's false. Case 8, we have the same true for both of them, so that case is true. So these are all the possible outcomes of that statement depending on whether each of these three statements is true. Alright. Rewrite the statement in symbolic form. Then construct a truth table for the statement. If I do all my homework and don't party tonight, then I will pass the test. Let's come up with some statements for those. We'll call H the I do all my homework tonight. P will be I party tonight. T will be I pass the test. And to write out this statement, this sentence, this compound statement, symbolically, let's see. I do all my homework and I don't party. If I do all of that, then I pass the test. So let's look at our possible outcomes. I've already filled in. H is going to have 4 trues, 4 falses, and then P will be true, true, false, false, true, true, false, false, and then T will be true, false, true, false, true, false, and so on. Not P will be our first column because we're going to need it here. So not P, we just flip all the P's. It becomes false, false, true, true, false, false, true, true. Alright, now in order to do this, H and P, not P, we'll be looking at our H column and our not P column. And this is AND, meaning they both must be true. So in the first case, they're not both true because the not partying is false. In the second case, the not partying is false. In the third case, they're both true, so the AND works. In the fourth case, they're both true, so the AND works. In case 5, we've got false. Case 6, false. Case 7, false. And case 8, false. These last 4 were false because all of these H's are false. And for the AND, we need both to be true. Alright, we seem to be missing a T here. So, if H and not P, then T. So, with the if-then, the conditional, the only thing we had to worry about is when this is true and this is false, then the whole statement is false. Otherwise, it's all true. So, we only have to worry about where this is true. So let's look. H and not P is false. Well, the if-then statement holds then. H and not P is false. Then the if-then statement holds true. H and not P is true. I'm going to scribble out a couple of columns to make sure I'm looking at the right one. H and not P is true, and so is the test. So it's true. H and not P is true, but test is false. That's the one case in which this statement is false. Now the rest of these cases, my antecedent is false, so the statement must be true. Again, with the conditional, the only problem we're looking for is when the antecedent is true and the consequent is false. If this is the case, then the whole thing is false. Otherwise, it's true. So there we are. Let's see.